Okay, so we're going to be creating a matching engine. Previously, up until this point, I've been creating them using a sorted dictionary. Now, it all worked fine, but the problem with a sorted dictionary was that it's not a part of the Python package, and so the package is from an external package known as sorted containers. So if they wanted me to implement it using only Python standard libraries, dictionary from sorted containers is not something they would use. So something similar that we can use to this is a heap. Heap also does a log n insertion, log n all of one, actually all of one retrieval since at the top, or log n deletion as well. So let's get into it. So first we would need to import the heap Q model. We'll be using heap Q. And similarly, just like before, we'll have a bit book and a offer book. First things first, I think I would like to define our objects that we'll be using. So we will have a order object. We're initializing this. We'll be initializing first. So we'll have a direction of it. So that a bid or it's an offer, we'll have the person related to this order. We'll have the security that they're trying to buy, the price per security, and the quantity that they're wishing to buy as well. So we'll simply initialize these values. Security, self.price, this is the price, and the quantity as well. So that's going to be the order. Similarly, when a trade does occur, we want to record these trades as well. Record a trade. We're going to write down the buyer and the seller. So it's the offer, the buyer is the bidder, the security that they bought, the price, the quantity report as well. We could probably have a time as well. Does that sound alright? Does that sound like a pretty reasonable trading class to me? Is there any other information that you think I should add upon? Or does this sound good enough? Cool. So before we get into the actual matching engine, let's create these bid books and offer books first. And these will ultimately store the offers and the price. So the most important thing that we need to know is the price priority. It's the priority of orders. So first, that's really deep into the price side of it. So by using a heap queue, Python a heap is defaultly implemented using a minimum heap. So let's think about if that's right for our bid. Let's create a bid book first. So in a bid book, what does this mean? It means it's going to have the resting orders of bids. It means we're going to try matching it to an incoming offer. An offer is someone trying to sell their security. If I'm trying to sell my security, I want to get the most amount of money possible. So I'm looking for something that is at worst the amount of money that I put my offer up, and at best, which is something greater than that. So that tells to me that for the bid book, we require a maximum heap. But we'll just initialize a heap like that. And then we're going to have heap a, a heap. So the maximum heap for our bid book. Now, using the maximum heap, we can always recall the, the highest number of the price. Then we actually need to store the orders for this price point, and for that we can use a dictionary. So let's call it book. It's going to be a dictionary. Now the key and values of this dictionary will probably be, so the key of this dictionary is going to be price, and the value is going to be a list. It's going to be a list. It's going to be some sort of list of orders, I imagine. But that's going to be it for our bid book. And let's try to look into what our add order might look like. So for this, we'll be taking in let's be a bit more pedantic than orders. We're going to be taking in a bid, which is going to be a type of order. It's going to return nothing. So we said that we first need to check, does this price exist within our book? If not bid.price in self.book, this means that the price has not been recorded. Then we need to add it to our heap. So heap q.heap push, we're going to be pushing, we're going to be adding a new price into a heap. This will sort it out. So we're going to pass through the heap, which is going to be self.heap, and the value for it, which is going to be the price. Now that we've inserted that into a heap, we also need to keep a record within our dictionary. So we're going to create a mapping between. So self.book bid price is going to equal. We can use a list, but I'm just thinking later on when we do iterate through the orders, we will have to, if the order is fully fulfilled, we'll have to pop it. And then for pop functions, we'll be popping from the very first index left. And we can use pop zero, but for this, we might be using a GQ, might be a bit more performative. Since these allow for more performative popping from our first, which is going to be the form of pop left. So we'll be using a GQ for this. Now, once we've created that, we want to append the order into our GQ. So self.book bid.price dot append. We're going to append this bid to it. We don't need to do anything for the heap, as the heap literally only records the best price possible. Now, we did say that for our bid book, we're going to have a maximum heap. Since Python's default implementation of a heap is a minimum heap, we need to negate the bid price such that the opposite side, this will now be a maximum heap. So let me just write it. And then right here, negate price to. So that's good enough for our add order function. Now let's go into our match function, match stuff, and then for this one, we'll be taking in a offer. It's going to be type of order as well. Let's say that for this, we're going to output a list of orders, not a list of trades. This is all the trades that have been executed before. Obviously, we're going to have arrays that we're going to output at the end. Now, for a match, obviously the first thing that we need to check is that there are actual bids within the bid book. And we'll be doing this check here because we will be mutating the bid book as we go on. So while a book does exist. We can look at the book or we can look at the heap. Let's look at the heap. I'm not too sure what is more performative, to be honest, but I imagine they're quite similar as we just check it with any entity. So while a heap exists and there exists more than zero offer quantity to be traced. So this means while there are outstanding bids and while this offer hasn't been completely executed, this is where our loop's going to happen. So we first need to find out the best price. The best price we said would be at the very top of the heap. So let's get the first object in our heap, the head of our heap. Remember that when we did store the heap, we did negate the value. So here we need to negate it once again to get the actual real value of the best price. Now this is an important one. Now let's think about it. Now an offer has come into our bid book. Our resting order is the bid book. Now when someone's selling a security, they want to get as much money as possible. So we need to make sure that the best price is greater than or equal to the price that they're willing to pay. And if that is the case, then that means we can get the list. That means we can get the list of orders. We can actually now start iterating through this list of orders. Now these list of orders are going to exist within our self.book dictionary. Let me just cast it to a list so it takes a snapshot because we'll be mutating this DQ. And it's very okay if you mutate the DQ as it triggers through it. So for order, the list of orders, we're going to cast order to a type of order. Now we're going to find out how many stocks will be changed. The amount of stocks being exchanged will always be the minimum amount. So amount traded is always going to be the minimum amount. So order.quantity and offer.quantity. And after we find out the minimum amount, we can simply subtract this amount from the order quantity and the offer quantity as well. Also here we need to create a new trade object. So trade is going to say the buyer. So for this, the buyer is the resting order, the order dot person, and the seller is going to be the offer dot person. The security is going to be order dot security. I can use either or for this, but it doesn't really matter. The price here is going to be the best price, and the quantity is going to be the amount of traded. So we're going to add this. We're going to add this trade to our output array. So output dot append trade. Now, one thing what might have happened here is that yeah, so this makes sense up to this point. Does it look good? Yeah. So one thing that might have occurred up to here is that let's say there's a case where all the bits have been sold, but there are still all the bits have been sold, yeah. So the offer quantity is 0. If that's the case, we want to delete this from the queue because this trade has been fully fulfilled. We're going to check it. If order the quantity is equal to 0, we're going to pop it from the list of orders. So self dot put for this best price, because we're still in the context of this order, which is at the very front of the queue, we simply do pop left because this is a DQ. DQ, yeah. Let's say we've done all the orders and all the orders have been popped. That means for a price, there are no more orders. Then what is the case? Then what do we need to do there? Well, first we need to delete this price from the dictionary, and then we need to delete well, we need to pop it from the heap as well. We need to pop it from the heap as that price. There exists no more orders for that price. So if not, so the best price, this means that this asks, are there any orders for this price? So it says if there's nothing, so there's no more orders for this price, then what are we going to do? We're going to delete. We're going to delete this mapping because this key maps to no values, and this is bad. Well, it's not the worst thing in the world, but it's good to just keep it deleted if we don't have a use for it. But more importantly, we do need to pop. We do need to pop. We do need to pop. Yeah, we do need to pop from our heap. Now let's say that's the end of the best price does suffice this offer price. Now what if it doesn't? If we look at the very best price and that doesn't suffice to the offer's price, then no other bid price can suffice, right? Yeah, that makes sense. Yes. Because if the best couldn't sufficiently meet the offer's price, then the remaining bid prices will not as well. So if that's the case, we'll simply break out. There can be no more trades occurring at this point. And we're going to return outputs. Now I'm just thinking, if the else's break, let's say an offer came in and then we couldn't fully do it. There's still 50 shares left because I couldn't find the best price. Then we still need to create a resting order for that offer. But we don't have context into the bid book at that point. So this will probably have to happen. This will have to happen in a higher scope, which does have access to the order book, the offer book, sorry. So let's also return, this will return as a tuple. Let's also return the amount of remaining 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 quantity. So we're going to return a tuple of a list of trade and then integer. So that looks good for the bitbook match function so far. Let's see what this might look like for an offer book. So we're going to have a offer book. For an offer book, we are going to have a minimum heap. Same. Then for the add order, we're going to be taking in an offer. So if not, we're not going to make it anything because we do want the minimum value, do we? Let's think about it. So if a bid comes in, I want to sell something. No, I want to buy something the lowest amount of money possible. So I do want the minimum value. Yeah. So it's going to be for the lowest amount possible, and that's for the match. So when I match, then a bid is going to be coming in. So while my heap exists and Bitcoin is more than 0, I'll be getting the best price. And at this point, if the best price is smaller than or equal to the bid price, a trade will occur. So somewhere here, and then we just need to get a trade. So what's our first one? It's the buyer. So the buyer here is going to be the bid person and the seller is going to be this orders person. Everything else can stay the same. We're going to be returning the bid as well. So now let's actually create the matching engine that will take care of matching engine between these two. So when we first create a matching engine, we're going to initialize the bid book as bid book, and we're going to initialize the offer book as offer book. And then let's also have a list of all the executed trades. It's going to keep a record of all the executed trades so far. Then we'll call a match function. This is going to take in an order. We don't know what side of the order might be yet. And let's say it returns a list of all the trades that have happened for this exact match. So first, we're going to check the direction of the order. So if order direction is bid, if it's a bid, let's try those first. So if it's a bid, we want to be looking inside the offer book to see if there's any outstanding offers to match it to. So let's say if the offer book doesn't exist, if there's nothing within the offer book, then we'll instantly add this to the bid book. But if it does exist within the offer book, let's say an offer does exist in the book, but we're not too sure, then we need to call the match function for the bid book. It returns output, so executed trades, the remaining quantity. Remaining quantity is going to be the bid book dot match. I'm going to try match it here. But we're going to output, okay, trades. So we're going to extend the trade. We're going to extend the trades with the extended chains that we've done. And then we need to check if remaining quantity is greater than 0. This means that this bid order has only been partially executed. So there are still some remaining stocks left, and we need to add that to the bid book. So first things first, we need to update our order quantity, the amount of remaining quantity, and then we'll create a resting order for this bid under the bid book. So order. This will ensure that those partial executions will still exist within the bid book as well. Now let's look at for the opposite direction. So if this is a order, offer, so we're going to check the bid book first. If it doesn't exist, then we're going to add it to the offer book. And order. But if an offer does exist within the offer book, I'm going to do executed trade. Remaining quantity is going to equal to offer book match. That's simply the order. And we're going to extend our trade. That. Good. And if there is more than if there are more remaining quantity after, so that's more left, then our order dot quantity is going to equal remaining quantity. We're going to create a new resting offer inside the offer book. Stats. And then lastly, we said we will return a list of trades that has happened for this exact match. So we're going to return trade, which initializes to the array here. So it looks like this will work fine. Let's go over some cases that we like to talk about. So let's say we do it in Python. Let's say this is my bid book. Bid book, I have the offer book. Let's say we have some executed trades. And let's say let's say Sally. Let's say Sally puts in a bid offer for Apple. Sally bid offer for Apple at $100, just buy 150 stocks. Then there's Bob, who is putting in an offer for Apple at $90 at 150. So let's do Sally's offer, bid first. So Sally offers goes into the matching engine, and because it is a bid, it's going to go up here. It sees, and then we see that the offer book is empty because there are no existing offers. So this bid will instantly get added into the bid book. Next, Bob's offer for Apple will come in. So as Bid's offer for Apple comes in, goes down this direction. It sees that there is more than one. There actually exists offer order. There's something in the bid book. So go here, and it's going to go into the match function. So it's of our. Oh, yeah, this is quite wrong. I got it wrong. We should be doing the offer book here and the bid book here. Yeah. So it goes into the bid book, and then the heap exists. There's Sally's order, and the offer quantity is 150. So we get the best price out of the bid book at this point, which is $100. And then we see, is this price greater or equal to the offer price? 190 it is. So a trade will occur here. So we're going to get the list of orders and then for order. So there's only one order, which is Sally's order. And then we're going to find the amount traded. It's the minimum between the two. And since they're both sitting, it's 150. We subtract 150 from both. We create a trade, order per person. So the buyer at this point is going to be Sally, the seller being the offer person. Then we check, is the order quantity zero? Sally is zero. So we're going to pop left from the DQ such that this order is going to be deleted from this price point in the bid book. We exit the for loop as there exists no list orders. Then we check, do there exist any orders for this specific price point? And there's not. So we delete this from the price. So this price in the bid book doesn't exist anymore. And then we also pop from the heap, as this is no longer the highest price point that currently has offers available. This if block. And we go into the while loop, while self a heap, so that's false. And conversely, offer the quantity for the zero is false as well. So we break out. We're going to return the output, which is a list of trades, and the offer quantity. So extended trade is going to record that one trade, and it's going to be zero. We're going to extend the trades as well. So we just return the executed trades for this. Yeah, I should be extending the self.trades. Yeah, no, I should be extending executed trades here. Cool. And then since remaining quantity is zero, as this order has been totally matched, we don't have to do any more of this, and then we return the amount of trades, which is one for this case. So we will see Alice, Bob, for Apple, price of 100. It's going to execute at $100, 150. Yeah, so it's going to execute at the resting order, which is the price, which is in the bid book. And the resting order in this case is the bid book. And since the bid book price is greater than or equal to the offer book, this will occur at the resting order. So Bob got a deal. He only wanted to sell for 90, but he ended up getting 100. And Alice was able to buy the stock at $100. So that's good. Yeah. So it's the matching engine using the heap rather than a sorted dictionary. So